Hi everyone, welcome to our second talk with Libra. He's going to talk about the ReZer0 loader. It's going to be a fast talk of 30 minutes. So if you have any questions, just ask on the YouTube and we'll transmit to Libra. Rooms to you. Thanks.
Thank you very much. Good evening, everybody. It's 9 o'clock my time. I think it's 3 Eastern time, if I say that correctly, for those in Canada and for those around the world somewhere. It should be any time of the day. So welcome to my talk. Today I'll be talking about the ReZer0 loader. I'll start off with a short PowerPoint with some introduction and a bit of basic terms and programs that we will use. It can also be seen in the table of contents. So first I'll talk about who am I, then what is the ReZer0 loader, the use tooling, and then we'll swap over to the live analysis. If you have any questions, then feel free to put them in the chat. I'll get back to them. And then hopefully all questions will be explained during the presentation itself. If not, I'll get back to you. If it's too long, we can take it offline and discuss it further via another way, via the Discord of the Hackfest, or we can chat in the YouTube chat afterwards. So moving on, who am I? My name is Max Kersten. I go by the nickname of Libra or Libra Analysis on Twitter. January 2019, I graduated cum laude from my bachelor in IT security. In the meantime, I also worked as an Android malware analyst with Fabric. In my spare time, I write blogs about reverse engineering, mainly working on my binary analysis course, but also working on some different programs. The programs I make are open source on my GitHub, such as Android Project Creator. In 2019, when we could still get together physically, I gave a workshop at BotConf about static Android malware analysis. And this year I gave a virtual talk for the conference about Android Project Creator. I'm currently working at ABN AMRO, which is a Dutch bank, as a threat intelligence analyst. So moving on to the ReZer0 loader itself, what is it? So the name consists of two terms, basically. You have ReZer0, which is the name of this specific loader. That brings us to the first question, what is a loader? Well, a loader is a program that loads, as the name already indicates, a given payload. Now, this payload can be encrypted or otherwise obfuscated to cause antivirus to not detect the loader itself and the payload. And it's usually decrypted during the runtime. So that means that the loader starts, it decrypts the payload, and then it starts the payload in one way or another. Maybe there are various ways included. So if you were to persist the loader, you would actually persist the final payload, but then still in a packed or encrypted form. Now, for this specific loader, it can persist and it can launch payloads in various ways. We'll see the exact ways in a bit when talking about the code and when analyzing it. The payload can be embedded, it can be downloaded from a remote source, and for a full write-up after the talk, you can click on the link that's in the PowerPoint. I'll publish these slides this afternoon for you guys, so that is after the talk. I think 20 minutes after, I'll put the slides online and I'll tweet the link to it. So you can read the complete write-up, including a step-by-step analysis. But over the highlights, you will see that in this talk. So this sample was obtained via a malware analyst at Talos named Nikhil Hedge, and he provided an outline in a ClamAV blog post of a sample. And this was one of the stages. So his blog ends where this one starts, basically. So it's a continuation of sorts. So you can also check that out if you're interested. So this specific sample can be seen as a pyramid. So the ClamAV blog post talks about another loader, which then loads the ReZer0 v4 loader, which in the end results in mass loader, be it in a somewhat obfuscated form. So in the live analysis, I'll be using two tools. One of them is D for dot. It's a free tool, open source, and you can deobfuscate .NET-based binaries with it. Now also note that there is D for .cex, which is used to deobfuscate computer X obfuscated binary. So this is not present in the default way, and you'll see use this CX version as well during this talk. It doesn't matter for this sample, just the default that I use. It can deobfuscate either known obfuscators, such as the computer X, but it can also handle unknown obfuscators. Now, in the case that it's unknown, there are some basic rules within D4.0 that will help you out. And in the latter case, it will also clean the binary. So if there is a weird naming scheme or other things that are odd or at least not easily handleable for a human analyst, it will clean it and help you out with that. And I'll show the difference between the original payload and the clean one once we dive more into it. Then as a second tool that we will be using is DNSpy. Stands for .NET Spy. It's a free and open source tool to analyze and debug .NET-based applications. You can also patch applications with it, but that's out of scope for now. So you can show the intermediate, you see there's a typo there, but it should be intermediate language either as raw, so some form of disassembly, let's put it that way, or you can view it as Visual Basic .NET or as C#. So whenever I'll be using this program, I'll be displaying the source code as C#, or rather the way the intermediate language is represented. So during the live analysis, there are basically 4 points that I want to touch upon. This does mean that for some parts of the loader we'll be skipping because this might involve either too much manual work or it just might take too much time for a 30-minute talk. And we're currently already nearly 9 minutes in, so that's fine. So first off, I want to clean the sample. I want to show the difference between the non-clean and the clean sample using DE for dot. Then I want to get a better understanding of the loader, as if I were to look at it for the first time. I will be switching over to a more clean version as well to save some time. The difference between the latter clean version is the fact that I manually renamed functions and classes in there already. Then we'll talk about how to manually extract the payload from the loader, because in this case, we, spoiler alert, are talking about a embedded payload, and also the settings for the loader. And then I'll also talk about the automation of the extraction. So moving on, we have the binary here, which is named ReZer0_v4.bin. And I have DNSpy open on the left here. Now I can drag it in, and then I can see that it loads it. So I can view whatever is in here. And automatically, DNSpy points me to the entry point, to class.function. So usually this would be your program.main, but in this case, we can already see that this is not nice to read. Now diving into it, we do see that there are some if statements, some booleans that are either triggering or not triggering said if statements. And we also see that the location of the current binary is stored. Now this is already named location. So if we just scroll through this, and in general, the names seem to be less human friendly, but the rest of the code seems pretty normal. So what we can do is we can move over and use D for dot. In this case, I have D for dot here. I provide the path to my binary itself, and I simply press enter. So then it states the version, who made it, and then it says it detected an unknown obfuscator. That makes sense because this is not a necessarily known obfuscator in the sense that there is a recognition in here, but it does clean it, and it's also renaming all obfuscated symbols. So all obfuscated symbols mean that symbols that are not nice to read for me, such as the characters that are given here. So it saved it as the same name, but then dash cleaned prior to the extension. And what we can do, we can just drag this into DNSpy as well. And if I just open the way that the classes are structured, you can automatically see that instead of these names, we are now looking at class 0, class 1, 2, 3, 4, etc. So that just makes it easier to handle from our side. Now, if we look here, then we see that we have class 8.main as a main function. So I'm just going to remove this from the list because that makes life easier. And we can move on to the main function here. Now, as you can see, the if statements are also a bit cleaned in the sense that previously we had a Boolean, and then the Boolean was evaluated within the if statements condition. However, this has been merged into one for now, which makes it also easier to look at the code in this sense. So we can still see that the location is requested of the current application. And if a specific integer equals 1, then thread.sleep is called with a specific value. And this brings us to the usage of these variables within this class, where we can see integer 11, string 2, which is an array of at least 35 in size. We have integers all over the place, as well as some other methods. And if we were to go down to the declaration of these, we can see that these all are private static fields. We can see here that for all the strings, because this is the string type and is returned by the s method 0, which requires an integer. Every time this is called, we can see that we get a string in return. So this is some form of encoding or encryption. So if we were to look into this, we can see that this is more of a wrapper function. And the wrapper function itself first blocks an instance of the class. It has a result variable which is returned based on whatever is returned here. And it does some magic with it, either here, or if we go back, it makes the use of this function, which is given below here. And this one is quite lengthy and also might not be the best decompilation that we ever had due to the casting. Now, if we were to look at this, we can immediately see two things. One, we can recreate this. The dnspy gives you the option to do so, where you can export something to a project. If you do not use a clean version, you will get an error, at least with this program. So the clean version is exportable. And what you can also do is you can breakpoint on the return value here, or both. You can do it here, where the lock is set. Now, what you can do here is, since this is basically a string decryption function, it requires an argument and then returns the result. So you can basically dynamically get all the strings back. It's a bit of a tedious task, and there are probably other ways as well to do it, but there are not too many in this binary itself. So if you were to do this, and I can run it here. Doesn't have a valid extension, but it shouldn't matter for our case. It hits the breakpoint, and we can see that integer 3, which is the argument of the function itself, is given the value -15, etc. Now, if we were to continue the execution, we should return here in result. We can see here that this is a rather specific string. So what we can do is we can create a mapping between the input argument and the output. And what we can also do is we can use the analyze function, which you can do with Ctrl-Shift-R, or right-click as I just did, to find the cross-references to this function, find where it's used, and then for each of the uses, you can use the, you can click find the argument, and instead of going over it, because not all functions might be reached, so in this case we saw the hit, and I know this by heart, so it's not as if there should be a hint in this case. If we go down, then this is the first string here that we just saw being decrypted. So if we were to move the execution from here, which is line 76, the return, we can also move it back to the lock. So what we can do is we can set next statement, Ctrl-Shift-10 on line 64, and then instead of exiting the function, we're actually basically at the top. Now, what we can also do in the local tab on the bottom, we can change the value here to a different one. So if we were to go back to one of the, get a nice view of that. Let's see, if we were to take what else is used in this case, we can see here that this is a string array, but the string array is split based on some value. So this is one of the functions, and this is another. So we can take this value, we can copy that, and we can put it in the value here. So this ends on 605, that's in there, but now we have 749, which we copied. And if we were then to go back here, would continue the execution, you can see that we have two pipes, which is basically the splitter for these settings. Now, if you do this, then a lot of the other functions will become apparent as well. But in this case, we will be cheating and we'll be swapping over to a .NET project that I created upfront, where I renamed the classes, functions, and fields. Now, as you can see, the value that was obtained here is 30, and it does it times 1,000 because it requires you to put it in as milliseconds, whereas these settings is easier to provide it with in seconds, so they do it times 1,000 for you. So it should sleep in this case. So this is true. And the comments here for true and false, they are put there because the sample has a specific configuration, whereas the loader has more capabilities than this specific sample uses. Now, if we were to wait for this, then you could wait for 30 seconds or you could skip it. And we can see that it could display a message box. In this case, that is false, so it's not going to display a message box for us. But it should detect the, it shouldn't detect the virtual environment. And it has a function and a check. So the check here is put there based on the settings that are within the loader. And then we have the function itself to detect the virtual environment. Now, if we're to look into that, we can see that we have a check to get values from the registry, and then to check if it contains a certain value. So in this case, it checks for VBox, VirtualBox, VMware, and there are quite some different things here. So it checks for the graphics adapter, for example. It checks for the for wine in this case, if you were to run and emulate it, and then it either returns true or false if it found something. And if it should check and it finds something, because then both are true, then the program exits. So it just cancels itself when it's running in here. So it can also detect sandboxes, and it works based on the same thing. But in here, it uses an argument, which is the location, which is the current location of this program. Wherever it's running from, it gets the location, passes it here. Now, in this case, it shouldn't detect the sandboxes, but if it were, then we can see here that it looks for different versions. Again, so this is quite a lengthy function on the horizontal scroller. So you can see that it checks for the string sandbox, virus, malware, Schmitty, current user, virus, sandbox. So there are quite some fields in here that it checks based on this. Now, should it download and run a payload? If that's the case, then it uses the file name and the URL from these settings, and then it does that. So to dive a bit more into the settings itself, it's a bit simplified here, but what you can see is the fact that it takes the resource name, gets the payload, and you have the setting string, which are numbers. And all these numbers are parsed by splitting on pipes, like we saw before when we did the dynamic run. Now, based on the settings, we can, in the non-simplified version, it just gets a specific index. So for the should set scheduled task, it's 1 here, but that is taken from a specific index from the array where the settings are saved. So we have the same for the URL. We also have that for the download file name. So it gets the file and then it puts it somewhere. So we can look at the code there. It just starts a new web client. It gets a temporary path, adds the file name, downloads it, saves it as the required path, and just starts the process. So you can download and run anything as long as you have internet at this point. Now we continue, we can also see that it has the possibility to set a scheduled task, which is used for persistence. which should be 1 to be true, and in this case it is true. So this loader actually sets a scheduled task. It takes the application data folder, then it adds the file name, and it adds exe to the end. So if it already exists, because only the first run should do this, and then the second one shouldn't, because otherwise the file is already present. So you need to handle that somehow, which they did by checking if the file exists. If it doesn't, because the exclamation mark in front, it will copy the file, and then it will set a scheduled task. Now, the way this scheduled task is set is basically by running a new process, the scheduled tasks process, and then it adds it as an argument. It does it hidden, so you shouldn't see anything as a user. Deletes the file afterwards, the temp file that is. So then we have different ways of launching. So we can directly launch the payload if that's present, but this loads it as an assembly. So that means that the payload should be a .NET based binary, and then it just invokes the entry point with the given parameter. If this fails, and that also is not where I wanted to go. If we go back to the main function here, if that fails, or if this is false and this is true, which is in our case, then it should launch the payload followed. So by process following it, it gets the values that are required. We have the PE payload, which is a byte array that is passed. It gets a location, and the last value is a boolean. The bool 0 is also passed to the hollow process. It does this 5 times, or at least it attempts to. This already struck me because I saw the same code before. This is taken from the GitHub of Nyan XCat, which is used to launch a hollow process via .NET. And then it creates the process, and it does the usual steps. Basically, get the thread context for either 32 or 64-bit, read it, add your segment, and then, in a simplified form, refer the control later on back to it. If you have more questions on this, I have a more detailed write-up on this part. So after I was done analyzing this, I was mainly wondering about one thing, which is how to get the payload automatically, because then I could search for the loader and do this in bulk. And that's where I found the flaw in the loader, which is the fact that they made it static. So what you also saw is that I put a breakpoint in here. I put it in this function. But if we were to put a breakpoint on main here, I would run this, then we don't hit the main breakpoint first. So I want to run this. You see, we first get into the string decryption function. And that makes sense because if we were to put back the values that we saw here below main, or rather here for the byte array, you can see that it's static, meaning it's loaded before the main function is reached. Now, if we were to have a look at the normal readable code, then you can see that it gets the resource by name. Then it decrypts phase 1, phase 2, and then you have the PE payload. But before you enter main, so before they do all the checks, if it's a virtual environment or not, then you already have the full decrypted PE payload in your memory. Now, in this case, what I did is I wrote an extractor for this. You basically provide it to a folder, and then it gets all files in there. Then it iterates over them. And if we go here, the logic in itself is pretty simple. So I provided some feedback for the user. So it writes a line like parsing this file now. It loads the assembly. So this is assuming it's .NET based, but we know it is because this is a .NET based loader. And then we iterate over the types within the file. And then we iterate over all the fields. And I am specifically interested in non-public static fields. So non-public, i.e. the private field that we're talking about, and it should be static. So it's a private static field, which is correct because this is a private static byte array. Now, if we were to dive deeper into that, we iterate over all of these, and there are only 10-ish classes, so with a few fields each. So that should be pretty fast, and it is. So then I want to get the value. from that field that we're talking about when iterating all these. And then I check if the value type is equal to byte array. Well, in case it is, I dump it to the disk. But I have an additional parameter here is I want to make sure that the first byte of the payload is 4D, and I want to make sure the second byte is 5A. Now, for those who have either dumped stuff before or are really good at reading hexadecimal, this is the MZ header that's present. So it just dump the full array, and then we have the payload. So I can run this, and then it'll take a bit to start, but in here we should see the output. As you can see, it found two files. It found both the cleaned one and the non-cleaned one. And it also prints the size of whatever we dumped. So that should be the same in both cases. And we can also see that it got the settings. Now, the settings, it's a bit of a boring part, although it's useful when you print it out. If the value is not a byte array, but a string array, then I parse the settings manually. So I just iterate over everything and see what is present and what not. And if it's present, I print it. So that gives us this result. So you can now do this in bulk. So the output here is the same. And if we were to drag the output, which is the extracted one, this is the one that's cleaned and extracted, and we can put that in in dn-spy. Now, if we do that, then you will see that it says pheno, which is a next step in the binary. You can see again that it's not really human readable. It uses Costura, which is a different obfuscator. But at least we have the second stage here. So this works. And we can also double check this. And I have 2 minutes left, so that's perfectly on time. What I can do here is I can go back to this class. And if I then go down, I can put a breakpoint on the byte array itself. Because now I showed you the automatic dumping. What we can do here is, and here as well for the next one. If I run this, yes, I want to run it and mind the file extension. I can remove these breakpoints, and then I'll end up here. So what I can do is I can step over, and then you can see the return values. So what we can see here is that we don't want to view 1,000 child items, but what we see here is that the S method 0 returns something, 2 and 1 returns something. So what we're mostly interested in is S method 1 from class 3, because that's the final function, because these all fit together. So from this, what I want to see is I want to show this in the memory window, memory 1 in this case. And then you can also see here that it starts with MZ. So what we can do is we can save this to disk, and then manual.exe to avoid accidental execution. Stop the execution here because we have the file. And if we move over to dn-spy up here, and we can load the manual, you can also see that it says the pheno. And if I open this further, you can see the Costura and the other data here. So that's the manual version, and the other one is for bulk. Moves to the last part, which is, are there any questions in the chat?
Seems like we're good. Just waiting a little bit.
If something pops in anyone's mind later on, my DMs on Twitter are open as well. You can just ping me a message and I'll get back to you on this. For those who want to view these slides themselves, just give me 15 minutes and the slides will be up.
Awesome. Thanks again, Leroy, for that. That's super appreciated. We'll publish your slide on the Discord and on the YouTube video at a later time. So thanks again, and we see everyone in the next conference in a few minutes.
Yes, thank you very much. And I wish everybody enjoyable Hackfest holidays.